Today we will discuss about the successive differentiation. So, as the name successive differentiation. So, we have studied about the simple differentiation. Differentiation, we can define before starting the definition of successive differentiation. Suppose we have function y is equal to fx. So, in y is equal to fx, we say that y is our dependent variable. Y is the dependent variable, and here is the x is the independent variable. So how to say that this is the dependent or independent variable about x and y? So suppose we have a function y is equal to x square plus 1. Okay, so when we say that x is the independent variable, so we are free to choose any value of the x. So suppose we put the value of x is equal to 1. So as per the value of x is equal to 1, so y will change accordingly. So 1 square is 1 and plus 1, so this gives us 2. When we put x is equal to 2, so we see that the value of y is equal to 2 square plus 1, so that is the 5. So we see that the when we change the value of x, according to the value of x, y will change. So here we can say that y depend upon x. So here x is the independent variable, y is the dependent variable. Now let's talk about the derivative. So that means suppose we calculate the first derivative, we represented as dy upon dx. So this can be represented as f dash x. So on intermediate level, we have calculated the differentiation, that be first derivative, second derivative. So this is known as the first derivative. And when we take about the second derivative, so we can represent it d2y over dx square. So this we can write down as y f double dash x. Okay, so we move to the main definition of the successive differentiation. So here we calculate a very that means one time differentiation, two time differentiation. Now we move to the main definition of successive differentiation. So the definition of successive differentiation is that, so we can say that the process of finding differentiation, the process of finding differentiation again and again, the process of finding differentiation again and again is called successive differentiation. So is called successive differentiation. Is called a successive differentiation. So process of finding differential again and again. So now we talk about the differentiation again and again means one time derivative, two time derivative, three time derivative. So we represent the derivatives in this way. So suppose we have function, again we write as y is equal to fx. So that means the first derivative. So we calculate the first derivative, or we calculate the derivative always dependent variable with respect to the independent variable. So derivative of dependent variable with respect to independent variable. So we denote it as dy upon dx. dy upon dx generally we denote it as y1, or we can denote it as y dash, or here we write down as f dash x. The first derivative we denote down is this form. And when we talk about the second derivative, so second derivative is write as d2y over dx square, means two time differentiation of y with respect to independent variable x. So this can be represented as y2, and we note down as y double dash, or this can be represented as f double dash. So we symbolize, we denoted as y1, y2, y3, and similarly we write down the third derivative. So third derivative of same function, that means y equal to fx. So we write down as d qy over dxq. That may be differentiate three times any function. So this can be represented as y3, and we write down as y triple dash or equal to f triple dash x. So similarly, we proceed for fourth derivative. So that means we write down the fourth derivative. So the fourth derivative of this we written as d4 of y upon dx raised to the power 4. This equal to written as y4. Y4 is equal to, that means fourth derivative. So we can write down as fourth derivative of this one and is equal to f4 of x. Okay, so similarly, we move to the next derivative. That means fifth derivative, sixth derivative, or we go for the general case. So for general case, we write down the nth derivative. Okay, so here we move to the general term directly. So we write down the fifth derivative, we write down the sixth derivative, and so on. So we write down the nth derivative. So this is our important part. So how to write the nth derivative. So nth derivative when we want to write the, so we write as d and y over dx raised to the power n, or this is equal to yn nth derivative, or similarly we write as y raised to the power n is equal to f n x. Okay, one representation is that. So when we represent capital D for stand for differentiation, and we write down D is equal to d over dx. So then this can be written as d and y. So this we can write as d and y. Okay, so symbolically we can represent it as d and y. So that means nth derivative of y with respect to independent variable x. So this is the nth derivative. That means when we talk about the process of finding differentiation again, so that is called the successive differentiation. Okay. So now we move to the first nth derivative. So how to calculate the nth derivative? So that means suppose we have function that means y is equal to x square. So we can calculate the second derivative. So that means when, for example, we have function y is equal to x square. So then when we want to calculate the first derivative, that denoted as y1 or y dash, you can represent it as, so with respect to x. So that means this is our equation 1. So differentiation with respect to x, y1 equal to 2x, and then we calculate the y2 is equal to 2. And the third derivative obviously will be 0. So the differentiation of constant will be 0. So that means we write this way, that d over dx, the differentiation of any constant will be 0. Okay. So when we calculate the differentiation of any constant term, this would be 0. So now we have to calculate the first formula. So that means to find the nth derivative. So we calculate to find the nth derivative. To find the nth derivative of x raised to the power n. So this is our function. So that means when we want to calculate the nth derivative of fx is equal to x raised to the power n. So now we write down as y is equal to x raised to the power n. This is our equation number 1. Okay. So when we process 3 to 4 times the simple differentiation, we do the same. So we write down the differentiate 1 with respect to x. So differentiate with 1 with respect to x, we noted y1. So y1 is equal to x, that means n, x raised to the power n minus 1. Okay, so you know the formula of differentiation. So similarly, then when we do for the again differentiate again, so differentiate again with respect to x. So we write down as y2. Y2 is equal to n minus 1 into x raised to the power n minus 2. So this is the second differentiation. Now similarly, we differentiate again. So differentiate again with respect to x. So when we differentiate again with respect to x, so we write down as y3. Y3 is equal to n minus 1, n minus 2, x raised to the power n minus 3. So we see that the when we differentiate one time, so we get the one constant term in the coefficient. When we differentiate two times, so we get the two term as a coefficient, and power is also decreased by 2. And when we differentiate three times, and we have three constant term in the coefficient, and power decreased by 3. Also we see that the second term, when we differentiate two times, then n minus 1. Okay. And when we differentiate three times, so n minus 2. That means third term, we see that. So subtract minus 1. So now similarly, directly on the basis of this one, so we write out then the nth derivatives. Okay, so then the nth derivative, so we write as yn. Yn is equal to, that means n minus 1, n minus 2, n minus 3, and so on. So the last term will be n minus 1, one term before. Okay, and write down the power of x is n minus n. So when we calculate the nth derivative, the power should be n minus n. So now we see that, so that when we write down this thing, so that means y n minus 1, n minus 2, n minus 3, and so here n to n cancelled, so minus 1 minus plus 1 plus 1. So then we see that what is the previous term for this, or of this term. So the previous term will be n minus 2. Okay, so n minus 2, it means that when n to n cancels, so this previous term will be 2, on also the previous term will be 3. So the power of x raised to the power n minus 1 means power of x raised to the power 0, and the power of any something is 0 means 1. So this can be written as, you generally write down this thing is as, so n minus 3, n minus 2, n minus 1, or n. So this is the factorial. So this is the factorial value of n. So that means we can write down this. So that means this is the factorial n. So here we see that the yn, nth derivative of which term? X raised to the power n is equal to factorial n. So that means this can be written as dn, nth derivative of x raised to the power n is equal to factorial n. Okay, so thank you.